let's finish off the lecture by the very importance of the takeaways and the questions that are still muggy to us. And there's no other lecture where this is more important than this one, because everything we're going to do from here on will rely on the concepts that we applied today or that we introduced today. And therefore, rather than moving forward, if there's something still muggy to you, I highly suggest that you move backwards and make sure that you understand whatever is not clear to you, right? So this is probably the most important thing you can do here today. Don't move forward if you are still not certain about certain concepts. Please take that time. This is time you will never gain again in engineering if you skip this step. But with that said, please complete your takeaways and the questions that you have. And let me move on to the actual checkpoints. And let's agree that we understand how to interpret the 3 different support types. I showed you pictures of that help you to really take it from the real world to an idealized paper version. And we can definitely check that off now. And the next thing we talked about was reflected in the little experiment that we did virtually here, because we didn't have a classroom today, but we had a student walking over the beam. And what we understood was that the vertical support reactions really depend on the location relative to the supports of the force that was represented by the student walking on top of that beam. So that is an important concept to understand today. The closer the student came to the support, the more that support had to support. So I can check that off too. I understand that. And we then talked clearly about the 3 different reaction symbols, and we understand how to translate them into certain restraints or into degrees of freedom. So we need to understand that the symbols clearly identify that there is a free degree of freedom and a restricted degree of freedom. And we had a whole table about that, the one with the 3 rows that had the roller, the pin, and the fixed support in it. And I encourage you to go there if that is still a little bit questionable to you. Then we also learned that for stable structures, we need at least 3 support reactions. We will talk more about this in the future, but today we understood that we always have to give 3 support reactions. In fact, I'm going to highlight this here. I'm going to mark this as very important, because all your support reactions will only be complete if you provide 3 answers. So all your homework from now on will have 3 answers for each problem. And the same is true for a quiz and a test. And therefore, I want you to understand that here. It's very important that we agree on that. Last but not least, we learned that we can use the rotational equilibrium to really solve these support reactions. So we only talked today about simply supported beams, but in the future we will take this a little bit further. But for your homework now, you understand that you can use the moment equilibrium, rotational equilibrium, to solve for all these 3 support reactions. And therefore, we are done with the conclusion page here. I encourage you to think deeply about what you understand and what you don't understand. And I say it again because it's so important in this case. Do not move forward if there's still something muggy. Stay here and watch it again. This is a very important concept that engineers need to be familiar with before they move on to the next topic. And you will see that you will be thankful if you have a solid understanding of what we talked about today, because the rest in the future will become much easier rather than remaining a puzzle to you. But that concludes this page, and we are now ready to talk about the homework. Let's take a look at our upcoming homework and the homework that we solve for simply supported beams, particularly their support reactions. And to give you an easy way in here in problem number A, you have the same forces that are acting at the same distances, right? So here everything is B, B, B. That means that the force F2 and the force F2 here act at the 3rd points. So think of this as 2 students with the same weight walking over the beam that stand actually at the same distance. Remember the scale example that we had here in the class today? So that is similar to what you see here. And you can just superimpose the results. So that gives you a nice, easy way to apply your own numbers and to study the knowledge that you just gained and to apply the knowledge that you just gained. And I believe you can definitely solve this problem with ease. But then let's get a little bit more intricate here. And let's actually change up the numbers. So here you see F1, F2, F3, F4. They're all applied with different values, but at equal distances. And that will also teach you one specific thing about how these forces apply. But I believe that's also easy enough. And if you paid attention in the video, that should be not too difficult. Of course, we also want to practice the knowledge that we gain through the forces under angles. So you have forces here at different angles and different distances. But just as before, all you have to do is draw the free body diagram and then calculate the support reactions. And that is everything you have to do for this problem. Now it becomes really interesting, at least in the classroom. I always get feedback on this question. And that is because it's challenging for students to grasp the angle here or how it applies to the system. So let me help you out with that. So remember that here, this symbol here has a specific meaning, and I explained that throughout the lecture, so I don't have to repeat that here right now. But there's definitely a force that is perpendicular to that surface. Sometimes there's also one that's parallel to the surface. But understand that in this case, the surface defines in which direction you have to find your support reaction. And so these two forces here actually act a little bit different if the support is angled. I mean, the forces act the same, but the support reaction reacts slightly different. But you can use your moment equilibrium to find the support reaction on both sides. And then please understand that you can always break this down into components that are vertical and horizontal. And together they might make the perpendicular component. But maybe I gave too much away now. But anyways, you can solve this problem. Just pay close attention to the surface and what that means to the support reaction. But if you really think about it, I think you will have no problem solving that. And then here, I understand that we did not talk about this in class today. There is something identified as M1 with a rotational sense and M2 here. So these are moments. This was not clarified in today's lecture, but this is on purpose because we want you to attempt these problems without us showing you every bit of the way. So just give it a try. This is not meant to not teach you something or to challenge you on something that we haven't taught you. We will teach you this in the future, but this is supposed to challenge you so that you can actually struggle through the problem before we will ask you and teach you how to do that properly. So that brings us to the last problem, which has a similar challenge in it. And again, don't get frustrated if it's complicated. That's not how engineers feel about solving problems, right? Engineers get excited when they have a problem that they don't know how to solve. It's what they are set out to do, figure out the challenge, and just give it a try. If you don't get it, it's not a bad thing. Before you turn in this entire homework, you will definitely get directions on how to deal with these moments. But there are two moments in this case, and we have a force that is a concentrated force somewhere in the middle of the beam or like somewhere throughout the beam. And that are all the homework problems that you have to solve for homework 5A. And this is exclusively for simply supported beams. I wish you good luck with that, and I see you in the next lecture. Stay safe.